Hello, everyone. My name is Yunhao, and I am a PhD student here at Cornell. I have about 12 minutes to talk about my research, and the first thing I decided is that I don't want to talk anything about definitions or protocols or system design or performance. Um, I do have these components in my research, and indeed, like if you're interested in these parts, we have a paper published last year at OSDI, which has everything above, and it received the Best Paper Award. And in this talk, I wish to talk about something that we did not write in the paper. Specifically, I wish to talk about some fun stories. And through these fun stories, I wish to give you I hope that I can give you the philosophical intuition behind my research. Let me start with my title. The title is Oligarchy and Strategic Manipulation in Byzantine Ordered Consensus. And the title might sound weird to you because the three terms seems very irrelevant to each other. And that is true because these three terms, they come from three very different fields. The term oligarchy comes from the field of social trust theory, where people study elections. They study like dictatorship, oligarchy, democracy, with an emphasis of mathematical rigorous. And the term of strategic manipulation, it comes from the field of game theory and mechanism design, where people study games and auctions, etc. And Byzantine ordered consensus is a term we coined, and based on the three words, you may guess that it comes from the field of distributed systems and computing. So the philosophy behind my research is one possible connection that across the three fields, and I will start the story from social trust theory. The first story happened in Florida back in 2000, and here is a screenshot of this Wikipedia page called 2000 United States Presidential Election in Florida. I think the table is much longer than this. I only gave you the first three rows. You can see that the first place, Bush, received 48.847% of support. The second place, Gore, received 48.838% of support. And the third place, Nader, received 1.64% of support. And what's interesting about this election result is that people usually say if Nader did not run for this election, it is very likely that the 1.64 support for Nader will more go to Gore instead of Bush. So that if Nader did not run for this election, Gore will likely to win the election. And in other words, Nader, simply by running the election, manipulates the result and make Bush win. And the philosophical question to ask behind this phenomenon is, in an ideal world, can we design an ideal election rule that eliminates this kind of undesirable manipulation? And unfortunately, the answer is no. And this is the first impossibility I will talk today, which is Arrow's impossibility result. The person is called Kenneth Arrow. He introduced this result in 1951 in his PhD thesis, saying that in general, it is impossible to eliminate this kind of manipulation in any election rule. And next, I will introduce to you how this impossibility has influenced the field of game theory and mechanism design. Let's consider a next story, which is an art auction. Here is a painting by Mark Rothko. I download the image from the internet. Let's consider we have two players in the auction, Alice and Bob. And in an auction, they have their private valuation of the painting. Say, Alice thinks that the painting was $5 million because she appreciates Mark Rothko. Say, Bob doesn't really appreciate this art, and he thinks that it only worth $5. And in an auction, they have their public action. They report their bidding price. Let's say Alice gave $4 million and Bob gave a $5 as their bidding price. If we run a classic second price auction on this input, what we will get is that Alice will win the auction, but Alice will only pay $5 instead of $4 million. And the argument behind second price auction is that if Alice is rational, she should be honest and report $5 million instead of $4 million because first, no matter Alice report $4 or $5 million, she only pays $5. And second, by reporting $5 million, Alice has a higher chance to win the auction. However, there are several assumptions in second price auction, and there are situations where it cannot control. For example, Bob may know that he's not likely to win the auction, so he may try to report a bidding price dishonestly, say $5,000, trying to revenge, basically. So there's nothing, for Bob, nothing changes. He still loses the auction. But for Alice this time, she needs to pay more. She needs to pay $5,000 this time for the painting. And in other words, effectively, Bob, by reporting the valuation dishonestly, he manipulates the outcome of the auction. And again, the philosophical question to ask is, in an ideal world, can we design an ideal auction mechanism that eliminates this kind of like undesirable manipulations? And again, the answer is unfortunately no. In game theory and mechanism design, there are a number of impossibility results, and I only list two of them here. One is called Gibbard-Satterthwaite, another is called Meyerson-Satterthwaite impossibility. So the history is that Arrow gave his result in 1951. Gibbard and Satterthwaite gave their result in around 1973 or 1974, right after Arrow received the Nobel Prize. And Meyerson-Satterthwaite came out in around 1980s. And later, Meyerson, his full name is Roger Meyerson. He received the Nobel Prize in Economics in around 2007, I believe. And because of his contribution in mechanism design. And now becomes the interesting part, which is we try to make a connection between these results and the problem that we study, the Byzantine consensus problem in distributed systems. And I will illustrate the intuition with this single slide. On the left of the slide, I list the three key ingredients in the story that I just talked about in the auction. In the auction, we have, like Alice and Bob, they have their private information, which is the value of the painting. They have their public action, which is the bidding price they report. And also they have an auction mechanism that maps from an action profile into the outcome of the auction. Here, action profile means the action from both Alice and Bob. Now, let's try to make a connection to Byzantine consensus problem. Basically, say in blockchain. In blockchains, every player also have their private information, which is the actual receive time of a transaction. Say I am a player in the blockchain, I receive a transaction, I know when I received the transaction, and that is my private information. Every player have their public action. They can report sequence numbers or timestamps or like some protocols that use dependency sets or dependency graphs. These are the public actions that players can make in a blockchain. And a consensus protocol is, again, essentially a mapping from an action profile into the output ledger of a transaction. So again, the question to ask here is that, is it possible to eliminate Byzantine manipulation, meaning that Byzantine nodes, they may give their public action dishonestly, different from their private information, trying to manipulate the order of transactions in the output ledger. If you are curious of why this kind of manipulation is important to study, there are a number of very nice papers from our Professor Arejou's group talking about this kind of manipulation in blockchains like Ethereum. And in my work, by making this kind of connection, we formalized a intuition of yet another impossibility we call the Byzantine democracy paradox, basically saying that in general, it is impossible to even eliminate this kind of Byzantine manipulation. And philosophically, it follows the intuition of Arrow's impossibility and follows the intuition of Gibbard, Meyerson, and Satterthwaite. So basically, this table summarizes everything I wish to share today. And there's one more story I wish to share as a last story. So Arrow's impossibility came out in 1951. And when Arrow worked on this impossibility in his PhD thesis, his advisor barely knows what he is doing. And after the result was published, at that time, many economists really hated the result. But after 20 years, people started to understand the value of the result. And I mentioned this, it even leads to a Nobel Prize. And I mentioned this story because I come from the operating systems community. basically I publish in SSP and OSDI, and in the community that I live in, people also sort of hate Byzantine consensus. Like there are even very famous magazine papers talking about Byzantine consensus, and the title is The Saddest Moment. Like 2 years ago, when I started this project at Microsoft Research, like basically very few people would like to talk about the project with me. No one would like to talk about it. It's a very cold topic in my community nowadays. But I think Arrow's story really encouraged me. And eventually, we have our paper published and received the respect from our community. So I guess that I wish to end up with, like, the lesson is that sometimes it just takes time for others to understand your work, and don't panic, don't worry too much, and don't give up. I will stop here, and I'm happy to take questions. Thanks for listening.
Thanks very much. Thanks very much, Yunhao. We have a couple of minutes for questions, if anyone.
Sure. Yes, Kenneth Arrow. Yeah, Kenneth Arrow. Unfortunately, he passed away 2 years ago, but yeah. So let me see. Nader did not cost Gore the election. Gore lost the election by himself. I think that is a political question. Maybe we are not answering here. Sorry. Mind sharing the full title of the paper again? Oh, the title is Byzantine Ordered Consensus Without Byzantine Oligarchy. It basically is very similar to the talk of my title. Anyone please speak up if you wish to ask your question. I don't really know which one I should answer here. They seem not questions to me. Anybody? No? By the way, feel free to contact me. I'm very happy to talk my research with you. Yeah.
Okay, well, thank you again.
Thank you, Ari. Thank you, everyone.